All right, assalamu alaikum everyone. Let's begin. So we were doing trigonometry in our last session. First of all, I will take your questions on trigonometry. If you have any problems, you can let me know about them. Specifically on graphs, we can discuss those problems. And then hopefully once you're done with those problems in the first, let's say 20 minutes or so, we will start our next topic, which is coordinate geometry. Okay, it's a very simple one, so we are going to do it slightly quickly. We are not going to spend a lot of time on this. Equation of circle is slightly more complicated. We are not going to be doing that right now. We will be doing the simple coordinate geometry concepts, most of which you already know from O levels, but they're going to be slightly, they're going to be a couple of new things. For example, finding angles between lines, etc. But most of it is the same as what you've done before in O levels as well. So that's what we want to do today. But before that, let me know if you have any problems on trigonometric graphs in particular. Okay, so you had a lot of time. I'm sorry I missed the Thursday class as well. We'll make up for that at some point in the next week or maybe this week. We might have an extra class this week, by the way. I'm keeping that option as well. So keep in mind, for example, Friday or Saturday for an extra P1 class. We might have it. Okay, so let's start with a couple of questions from this worksheet first. P1 trigonometry. Okay, so Hazim is saying question number 44, part B from this worksheet first. Let's start with this. 44B. Hazim, we've done this before, I think. Let me just check. Yeah, we've done this question before in class. This was on Tuesday, 13th of Feb. We actually spent quite some time in trigonometry. We've done a lot of practice in this. 44 is one that we have done before. Tuesday, 13th February, we did this. I did it towards the end of the class, apparently. Yeah, it was the last question that we did in this class on 13th Feb. Okay, you can have a look at that. Any other questions? Specifically, any questions related to graphs? Any graph questions, anyone from this trigonometry worksheet? How many of you are done with all the assigned questions? Can I have raise of hands? Please raise your hand if you're done with all the assigned questions from the worksheet. Okay, I'll have a look at that. But I only have like 2 hands raised, Aima and Hazem. What about the rest of you? Why are you guys not practicing? This is not how you do maths. Even if you understand every single thing in class, if you do not practice, I've said this so many times before, you are going to forget most of these things. So after a month, you could be panicking then because you would not remember so many details from these topics if you're not practicing. Practicing all those questions that I'm assigning and doing more practice from recent past papers. That's the only way to retain these concepts that we're studying. Otherwise, what's the point of doing so much effort? We spend so much time in trigonometry. If you're not practicing yourself, you will not remember much. You'll have to cover everything all over again. And there's not much time left now. There's only 2 months left. You can't be doing this at this point. Yes, Adam? Okay, so you just joined. Okay, all right. Okay, so if there are no questions from the worksheet, then I was actually expecting some questions on graphs because there are a couple of questions, I think, which are a bit tricky. But it's only going to help if you've done them first and then you tell me you're having problems in them and then we discuss them in class. Otherwise, I'll just tell you, okay, this is how you do it. You will understand that, but then you will not really understand what exact part was difficult in that question. Okay, so let's start with this one. So I'll start with those other questions as well. I wanted to do something from the worksheet first. Let's start with this question from Rijal 55. Okay. Part A or part B?
Part B, sir.
Part B, okay. Okay, question number 55, part B. Let's try this. Okay, so it says the diagram shows part of the graph of y equals a cos x minus b, where a and b are constants. The graph crosses the x-axis at the point C. You can see that here. This is the point C. And the y-axis at the point D. This is the point D. Find C and D in terms of A and B. Okay, so we know the graph, the function, the equation of the graph, y equals a cos x minus b. That's the equation of this graph. It says it crosses the x-axis at this point. That means it's the x-intercept, this point. And the y-axis at 0d, that's this point, the y-intercept. So we have the x and y-intercepts given. All we have to do is find the values of C and D in terms of A and B. Okay, now think about this. This point C that they've given, it lies on the graph. It lies on this equation, on this function. You can just input this here because it should satisfy this equation. For example, if y equals 2x minus 3, if we have a point 1 and minus 1 that lies on this graph, that means if you were to input that in this equation, left hand side would be equal to the right hand side. So in this case, minus 1 would be equal to 2 into 1 minus 3, and that gives you minus 1 equal to minus 1. So if there's a point that lies on the function, it has to satisfy the equation of that function, right? In this case, we know this point C lies on this graph. You just input that point here, cos inverse of C and 0. So in place of y, put 0. And then in place of x, put cos inverse of C. So you get cos inverse of C minus B. That's the equation that you get from this. Now, cos inverse, these are inverse functions of each other. Cos inverse, they kind of cancel each other's effect. And you're just left with 0 equals A times C minus B. What you want to do is you want to find C and D in terms of A and B. So you have C here, you can find the value of C. You can say AC equals B, and C turns out to be B over A. That's one value that you were looking for, the value for C. Then you have another point given here as well, 0D. That also has to lie on the graph, lie in this equation. We put that here as well, 0 and D. X coordinate 0, y coordinate D. Let's see what we get from that. In place of y, put D. In place of x, put 0. So you get A into cos of 0 minus B, that equals D. Now, what's cos of 0? You can evaluate this on your calculator. Cos of 0 will give you 1. So you have A into 1 minus B, and D turns out to be A minus B. That's D in terms of A and B. And that's all that we were looking for, the value of C and the value of D. Is that okay?
Yes, sir.
All right. Okay, now before I discuss those other questions from Ima, let me at least do one graph question because I feel like you haven't really attempted all questions, because otherwise you would definitely have had some problems in graph questions at least, I think. So let me see which questions I assigned and if there are any of them that we can possibly discuss right now. Okay, so I'll be asking you about some questions. Please raise your hand if you're done with these questions. Okay, the question number that I ask you about, please raise your hand if you're done with that particular question. So first of all, this is straightforward. 2 is fine. How many of you are done with 15? This one, the one that has this graph. Raise your hand if you're done with 15. 1, 5. Okay. $17. So I think only Hazim is going to be raising hand in all of them. I'm actually disappointed, to be honest. This is not how you have to study maths. You should be studying maths, because the last class that we had in trigonometry was on Tuesday. You had 6 days after that. You could at least do this much. I think there were only a few questions left from the worksheet on graphs. Okay, 17, only 2 of you are done with those. Okay. $28, I think we did in class that day. And this one, okay. What about 29? 29. Question number 29. Okay. No problem in 29? The last part specifically? Were you able to do that? The last part? Rijal, Neema?
Yes, sir.
Okay, good. All right, let's have a look at just one question from this worksheet then, one more from this worksheet, and then we look at those questions from Ima. This is question number 15. Let's just have a look at this quickly. Okay, there's a misprint here. There's an overlap of 2 questions. So I'll just separate them here. This is the question that we actually want to focus on, the one that has graphs. Let me just remove the rest of it. Okay, so the actual question is actually just this much. This is from a previous question. And this number here was 9. Okay, so we have this graph given. The diagram shows the graph of y equals a sine of bx plus c for x between 0 and 2 pi. We need to first find the values of a, b, and c. These are the 3 values that we're looking for. The values of a, b, and c. Now, how do you find these values? Remember the transformations that we did? This number that is multiplying outside, we say this is the amplitude of the graph. Remember, what's the original amplitude of the sine graph? The original amplitude is 1. What about the amplitude in this case? Where's the baseline? Baseline is at this in the middle of the maximum point of the graph and the minimum point of the graph, you can see the maximum point is 9, the minimum point is -3, baseline is right in the middle. That's this line. From the baseline, you can see the graph is going 6 units up and 6 units down. So the amplitude therefore is 6. Okay, and this thing A that's multiplying outside, that represents the amplitude. So if this value is 6, you can say A is supposed to be equal to 6. So we have the value of A from that. A equals 6. Okay. Then this C is also pretty straightforward. C, remember, we said represents the baseline of the graph. The baseline of the graph is moved to 3. Originally, it was supposed to be 0. If you did not have any number outside, then the baseline would be 0. Y equals 0, right? You have 3 here. That means the baseline has moved up by 3 units. The C represents that baseline. The value of C is going to be 3, therefore. So we have the values of A and C like this, that they were pretty easy to figure out. A was the amplitude and C was the baseline. What about B now? How do you find the value of B? What is B going to be?
2.
B is going to be 2. How do you figure that out?
The number of cycles that it completes at 360 degree.
Yeah, so that's one way to think about this. Remember, original period of the sine graph is 360 degrees, or in this case, it's in radians, 2 pi radians. Normally, it would complete how many cycles? 1 cycle in 2 pi radian. How many cycles is it completing now? It's completing 2 cycles. So this B can kind of represent the number of cycles that it's completing now in 2 pi radians. If it's a sine graph or a cos graph, in this case, it's completing 2 cycles, so the value of B could be 2. Or another way of thinking about this could be, the original period of the graph was 2 pi. The original period of sine graph is 2 pi, right? What's the period of this graph? It's only pi. It's completing 1 cycle in pi radians. So period has halved. If period has halved, this number is going to be 2. Because remember, we discussed this here. Whatever is this number, period is basically divided by that. So whatever is this number here, period is going to be divided by this number. So whatever the original period is, that gets divided by this. So that could be another way of thinking about this. You could say original period is 2 pi divided by this number B. That should equal the new period. What's the new period of this graph? Pi radians. So that means pi equals 2 pi over B, and the value of B turns out to be 2 from that. And that could be another way of thinking about this. But in this case, the working does not matter. It's a 1 mark question, as in you have 1 mark for A, 1 mark for B, 1 mark for C. You just have to write that value down. You could use any method for that. Okay? You can use any method for that, as long as you get the correct result at the end. Is this all right? The first part? Okay, let's have a look at the second part now. Now the second part says, find the smallest value of x in this interval for which y equals 0. Now, what's the function? The function is y equals a sine of bx plus c. We know the values of a, b, and c now. We can input those here. A is 6, b is 2, so that's sine 2x, plus c, the value of c is 3. That's what the function is. We want to find the smallest value of x in the interval 0 to 2 pi for which y is equal to 0. We put y equal to 0 and just solve this equation. What's the interval that we're given? The interval is from 0 to 2 pi. That's the interval. Let's solve this equation. We get sine 2x equals minus 3 over 6, which is going to be minus 1 over 2, right? Once we have this form, what did we used to do? We used to use substitution. You can say let a equals 2x. This interval is going to be adjusted based on that as well. If x is between 0 and 2 pi, what about a? A is 2 times x. If you place 0, if you put 0 here, the lower limit for a also turns out to be 0. If you put 2 pi here, the upper limit of a turns out to be 4 pi. Now, the upper limit kind of does not even matter here because you are just looking for the smallest possible value of x, right? So whatever is the first value that you get in the interval, that's all that you want, okay? So you just need the smallest value of x. So let's just solve this equation now. If a equals 2 times x, we say sine of a equals minus 1 over 2. Let's find the basic angle. We say sine alpha equals 1 over 2. The basic angle in this case in radians is going to turn out to be pi over 6. That's the basic angle. Now you think of quadrants. Sine is negative. Where is sine negative? Sine is negative in the third quadrant or in the fourth quadrant. These are the two possible quadrants that we have, right? So alpha could be here, the basic angle could be here, or it could be here. You start measuring angles from the positive x-axis. The interval is only positive, so you have to go in the anti-clockwise direction. The first angle that you find is this one. And that's all that you need, because we were looking for the smallest value of x. So whatever is the first result, that's going to be enough. The first result is pi plus pi over 6. And that turns out to be 7 pi over 6. That's the value of a. We were looking for the value of x. We put that substitution back now. A was equal to 2x. We say 2x equals this, and the value of x therefore turns out to be 7 pi over 12. This is the smallest possible value of x. Okay. If you were to look for the other answers as well, you would look for this value. And then since the interval is going up to 4 pi, you would go one full circle and then come back to this point again, and then again come back to this. You'll have 4 answers in total, where y equals 0. And that will give you this point, this point, this point, and this point. We were only looking for this one, and we've got that here. Is that okay to everyone? Any problems? Any questions, anyone?
No, sir.
No? Sorry, just quick a minute. Okay, let's have a look at those questions now. The ones that are not in the worksheet, but I'm asked about those from some recent papers. Sorry, I can't find them. Okay. Okay, now for this, you would need to know function notation at least. Although we haven't done functions yet, I think I can still expect you to know function notations at least, because you've done that in O levels, right? There's no other concept of functions involved. There's no domain or range or anything, or no inverse functions. It's just about this notation, okay? I can explain that notation to you as well. But apart from that, it's only trigonometry. There's no function concept involved as such. Okay, so it says the function f is such that f of x equals f of x equals a plus b cos x for x between 0 and 2 pi. And we're given that f of pi over 3 equals 5 and f of pi equals 11. We need to find the values of the constants a and b. Okay, let me write down the function first of all. F of x equals a plus b cos of x. Right, that's what the function is, and it's defined for x between 0 and 2 pi. We have one piece of information here, another piece of information here. All that means is f of pi over 3. That means if we were to input x equal to pi over 3, the value of y that we get from that, the value of the whole function that we get from that, is going to be 5. This is a point that lies on this function. So this point is pi over 3 and 5. Okay, so in other words, you can just do it like this. You can say, let's input, or let me just do it in function notation. Now that I've explained that to you, f of pi over 3, that is supposed to be equal to 5. When x is pi over 3, y is equal to 5. Similarly here, it says, when x is equal to pi, the value of y, the value of the function, is going to be 11. That means f of pi equals 11. That's the second piece of information that we're given. Just input those values here. What is f of pi over 3 going to be? In place of x in this function, we just input pi over 3. So it becomes a plus b cos of pi over 3. What is this number equal to? It's equal to 5. You replace it with 5. You have 5 equals a plus b cos of pi over 3. Or if it makes it confusing, I'm sorry, try it like this instead, like I wrote it before. So yeah, this is what we had given here. Let's replace this with a plus b into cos of x. Replace x with pi over 3. That is equal to 5. Okay, I think that might make more sense to you. So in place of f of pi over 3, I just put this thing where I replaced x with pi over 3. Okay, I just put x equal to pi over 3, and that result should be equal to 5. That's one equation that I have. Now cos of pi over 3, just evaluate this on your calculator. I think it's 1 over 2. So that's a plus 1 over 2 times b equal to 5. That's one equation that you get. Okay, you can simplify this to make it 2a plus b equals 10. Just multiply the whole equation by 2 to get rid of the fraction. That's what you get. You have one equation in terms of a and b.
Sir,
Similarly, yes.
sir, cos of pi over 3 is 0.9.
Make sure your calculator is in radian mode. Let me just confirm that as well. Cos of pi over 3. Yeah, it's 1 over 2. Your calculator needs to be in radian mode. Okay. All right. Now it says f of pi equals 11. Just replace x with pi now. So a plus b into cos of pi, that equals 11. That's another equation that we have. Cos of pi, put that on your calculator. That will give you minus 1. So you have another equation, a minus b equal to 11. Just solve these two equations simultaneously. and you would get the values of A and B from that. So in this case, for instance, we can say, let's make B the subject here. B equals 10 minus 2A. Put that in the other equation. That will give you A minus 10 minus 2A equals 11. 3A minus 10. Let me just show one more step. A minus 10 plus 2A equals 11. And then 3A equals 21. The value of A turns out to be 7. Put that back here. And B is equal to 10 minus 2 times 7, which gives us B equal to minus 4. So A equals 7 and B equals minus 4. So once you understand what this notation means, you just have to input those points in that equation to find A and B. Okay, I hope that makes sense. That was the first part. Let's look at the second part of this question now. Let's see what the second part says. Now in part 2, we have to find the values of the find the set of values of K for which the equation f of x equals K has no solution. Okay, f of x equals K should not have any solutions. F of x equals K. What are the possible values of K in this case? Now, what's f of x? We already have the values of A and B now. So A plus B cos x. Let me just write that here first. A plus B cos x equals K. What's the value of A is 7. So we have 7 minus 4 cos of x equals K. What are the possible values of K for which we do not have any solution? How do we think about this? If it was in quadratics, if the function was quadratics, was a quadratic function, then no solution would have meant b square minus 4ac is less than 0, right? But you can't use that here, okay? Because it's not a quadratic function. So please don't do that. B square minus 4ac, you don't even have any b square minus 4ac here. It's not a quadratic function. So we can't do that, okay? It's a trigonometric function. It's a trigonometric function. And we're saying this function should not have any solutions, okay? Now, remember what the values of cos of x are. What's the interval that we have for cos? Cos is supposed to be between minus 1 and 1. Cos of x is supposed to be between minus 1 and 1. If the value of cos x is less than or equal to minus 1, then it, or in fact, less than minus 1, equal to is possible. But if cos of x is less than minus 1, this is not possible. And if cos of x is greater than 1, this is also not possible. Okay. So what you can do is, one idea is, although when we have done, if we have done functions already, this might have been easier because you can just think of the range of this function. You can think of the range of this function. What's the maximum value? What's the minimum value? And then beyond those, you could say you would not have any solution. But one possibility here, so let me do it one way first. You make cos x the subject. That might make it easy for you to understand this. Make cos x the subject. If you make cos x the subject, what do you get? 7 minus k, that equals 4 cos x. And then cos of x equals 7 minus k over 4. You would not have any solution if either cos of x is less than minus 1 or cos of x is greater than minus 1. That means either 7 minus k over 4 is less than minus 1 or 7 minus k over 4 is greater than minus 1. Just solve these two inequalities. You get 7 minus k less than minus 4. And that gives you 11 less than k. If you write it the other way around, it means it gives you k greater than 11. Multiply this 4 on the other side as well. That gives you 7 minus k. That's greater than minus 4. And that gives you k.
Sir,
Okay, there's something wrong somewhere. Yes?
sir, it should be greater
Sorry.
than 1.
Yeah, it should have been 1. I'm sorry. That should have been 1 here. 1, this is 1. 4 multiplied by 1, that gives you 4. And that gives you k less than 3. So if you write it the other way around, you say k is less than 3. So there's going to be no solution if any one of these two conditions is true. Either k is greater than 11 or k is less than 3. If k was between 3 and 11, we would have solutions. Okay. Now, those of you who have done functions or remember some part of functions that you did in school, one possibility, one quicker way of doing this could be, this is the equation that you have. 7 minus 4 cos x equals k. This is the function. What is the graph of this function going to look like? It's a cos function. Cos graph actually looks like this. But since we have a negative multiplied here, it will be a reflection of that. So the graph might be something like this, right? And the shape might look something like this. But we're not interested in the exact shape. All we're interested in is there's going to be some maximum value and some minimum value in the given interval. What's the given interval? The interval is from 0 to 2 pi. Okay, there's some, is there any horizontal transformation? No, there's only vertical transformation, a translation and period. Okay. This is what the graph is going to look like. Okay. We will learn this later when we do functions. The way to find the maximum point and the minimum point of this graph is that you think about what happens to the cos graph. What's the maximum minimum value of cos? Cos is between -1 and 1. What you do is you put cos x equal to 1 here once, and that gives you 7 minus 4 into 1. That gives you k equal to 3. When k equals 3, that is when you have one extreme of this, basically. Let me just write it like this. Let's focus on this function first of all. Y equals 7 minus 4 cos x. Let's find the maximum point and the minimum point of this. Okay, so keep this separate. This is the function that we have on the left side, right? And on the right side, we have this function y equals k. These are the two functions. Y equals k is basically a horizontal line, right? It could be like this. Now, if we were to somehow able to find the maximum point and minimum point of this graph, we could then use that to figure out. We could then use that to figure out if we would have any solutions of this graph or not, of this function or not. Now, let me just repeat. Okay, let me just repeat that. This is the equation for which you're saying there should be no solutions. One function that you have in this equation is this, and the other is y equals k. In order to find the maximum point and the minimum point of this function, all you do is you say, since cos is between -1 and 1, you just see what happens when cos takes one of these extreme values. What's the value of this function when cos is equal to 1? You get y equals 7 minus 4 into 1, that gives you 3. What's the value of this function when cos of x equals -1? That gives you 7 minus 4 into -1, that gives you 11. So the range of this function, the maximum point and the minimum point of this function are going to be this. 3 is the minimum point and 11 is the maximum point. So when you draw the graph of this function, the lowest point of this graph, y coordinate at that point is going to be 3. The y coordinate at the lowest point is going to be 3, and at the maximum point, the y coordinate is going to be 11. Okay, at the lowest point, the y coordinate is 3, and at the maximum point, the y coordinate is 11. Now, if you have a line y equals k, when is that line not going to intersect this graph? It's not going to intersect this graph if it's above 11. It's a horizontal line above 11 here, or it's a horizontal line below 3. So you could say the sets of values for which this equation would not have any solution could be either k less than 3 or k greater than 11. So understanding that concept of maximum and minimum points of the function, the range of the function, that can help you do this relatively quickly as compared to what we did in the previous method here. Is that okay? How many of you understand this, the second method that we just discussed? Emma, is that okay?
Yes, sir.
Okay, so we will be discussing this concept of maximum minimum points of this trigonometric function later in functions as well. But I think that's fine for now. That's part 2. Yeah, so that's how you would deal with this, okay? Okay, let's try this one. I think we're not going to be able to start coordinate geometry today, and that's okay. We will do that tomorrow, inshallah. We'll start with that tomorrow and discuss most of the important concepts tomorrow, hopefully, because there's just it's a lot of overlap with your O-level syllabus, so we'll try to do that quickly. All right, let's try this. It says solve the equation 2 cos x plus 3 sin x equals 0 for x between 0 and 360. You were able to do this, the first part? You just have to divide by cos, convert it to tan, right? The first part is straightforward, right? Anna, which
Yes,
part
sir.
do you have problem in this case, in this
Sir,
question?
second and third.
Second and third? Okay. Let's try the second and third parts then directly. First part is pretty straightforward. It will convert to tan and then you can solve that. Okay, second and third parts. Sketch in the same diagram the graphs of y equals 2 cos x and y equals minus 3 sin x for x between 0 and 360. So remember what we discussed for this. How are you going to draw these graphs? Just put these functions in the table function on your calculator. You will get some points. Just plot those points and join them using the shape that you remember for sine and cos. What's the shape of the cos graph? The cos graph looks like this. Remember, this is the shape that you have to draw. The sine graph looks like this, but this is multiplied by negative sign here. So it's going to be flipped. It's going to look like this instead. Okay, just keep that in mind and just plot the points and join them using these shapes. That's all that you've got to do. Okay, now what's the interval? The interval is from 0 to 360. On your calculator, you can take, so you'll put it like this. If you have class viz, you can draw both of them at the same time. Otherwise, you can do them one by one. So in class viz, you could just do it like this. F of x equals 2 cos x. Make sure your calculator is in degrees mode. F of x equals 2 cos x, and then you could say g of x equals minus 3 sin x. Then start at 0 and at 360. I would recommend that you still take a step of 45, you don't have to do this manually, right? Your calculator is going to do it for you. Put a step of 45 there, but plot values at 90 degrees intervals first. If you understand the shape from that, that's okay. If not, you can plot those 45-degree points as well then. Okay, so sometimes if you don't remember the shape of the graph very well, you might not be able to figure out what the graph is going to look like. If that's the case with you, you can have more points. And how would you do that? By taking a smaller step, right? So if you take a step of 45, you'll have more points. If you take a step of 90, you'll have less number of points. So that's your choice. If you remember the shapes well, then a step of 90 is going to work for you. But if you don't remember the shapes very well, then you can take a smaller step so that you have more points, and they're going to help you understand the shape of the graph better. Okay, let's plot these points. Y equals 2 cos x. So maximum point, you can see what the maximum point in the graph is, what the minimum point in the graph is, and both the functions. Maximum point overall is going to be 3 for this function.
Sir,
and
it's
the minimum
2
for
cos.
sine is going, yeah, but overall for sine is going to be 3, right? So you have to consider the overall maximum minimum for the scale. So I'm just writing the scale for now. 3, 1, 3, 2, 1, 0, and then you have -1, -2. This is just to ensure that you have the right scale. Otherwise, once you've drawn one graph, you might realize later the second graph has to go above the maximum point that you have in the graph, then you have a problem. So you have to consider the maximum points of both graphs and minimum points of both graphs. So you have your scale according to that. Okay. So the minimum point of both graphs is -3 overall, and the overall maximum is +3. Let's just plot those points now. So at when x equals 0, you'll have 2 here, you'll have 0, you'll have -2, 0, and 2. The graph is going to look like this for 2 cos x. If you don't understand, or if you don't remember the shape of the graph, you can take more points at 45-degree intervals. Those points are going to come here, like this. And that will help you understand, okay, this is how the graph is going to look like. Okay. Now, some of you might be able to draw it without doing this at all. And that's perfectly okay. Showing the points is not important. It's just the shape of the graph that's important. And if you remember the values, if you can do this in your head, that's also perfectly okay. It should start from 2, then pass from 0 at these points, and then come back to 2 and go to -2 like this. You have to make sure that it passes through all of these points, but it's not necessary that you do that using a table function. If you're one of those who can do it mentally, that's perfectly okay. You can just draw the graph directly and using the concept of transformations. You see, this is 2 cos x. So the amplitude of the cos graph is just increased to 2, and the rest of the shape that just looks the same. So if you can figure it out like that, that's perfectly okay. You can draw that like that as well. Okay, so -3 sin x, it's going to start from 0. And then when x is 90, you would have -3. And then you have 0 again. Then you have 3 after that. Then 0 again. The graph is going to look like this. It's going to go down. Then at 180, it's going to be like this. My intervals, I think, are not very good because it doesn't look symmetrical, but it's okay. You have this and this. This is how the graph of the sine function in this case is going to look like. You're going to label these graphs. That's going to be important because you will not be using different colors. We'll be doing this using a pencil. Please do not use a pen to draw graphs, to sketch graphs. You will just have some blank space given in the paper. If you do it using a pen and you mess it up, then you won't find another blank space. The additional pages that you have at the end, they are lined spaces. So I would recommend that you always draw all sketches using a pencil. Do not use a pen for these sketches. Okay, so this is -3 sin x. So it's important to label those graphs then. This is -3 sin x, and the other one is 2 cos x. That's all that you have to do. And the second part, you can do that using the table function. That makes it so easy. You don't really have to think much. Just draw that directly like this. Okay, part 3. Now, part 3 says use your answers to parts 1 and 2 to find the set of values of x for 2 cos x plus 3 sin x is greater than 0. Okay, now for this, we need the answers from the first part. Do you have the answers from the first part? In the first part, we had this equation 2 cos x plus 3 sin x equals 0 for x between 0 and 360. Aima, do you have the answers from the first part? The values of x?
Sir, no, I did that in another notebook, so I was not able to find it.
Okay, so that means we'll have to do that quickly as well. It's going to be minus 2 over 3, right? Tan x equals minus 2 over 3. Yes, and then tan is negative, that means second quadrant or the fourth quadrant. And it's degrees. Tan inverse of 2 divided by 3. That's given me 33.69. Okay, so I think one answer is going to be 146.31 and the other is going to be 326.31. Okay, so if you do the first part, these are the answers that you would get from the first part. Okay. So assuming that you have solved this in the first part, 146.31 and 326.31, these are the answers that you get from the first part. Now, what does that mean? What's the equation that you solved in the first part? 2 cos x plus 3 sin x equals 0. How is that related to these graphs? You can see you have 2 cos x here and minus 3 sin x. If you were to equate both of them, 2 cos x equal to minus 3 sin x, and then rearrange this, you get t cos x plus 3 sin x equal to 0, and that's exactly the equation that you have solved in the first part. And that gives you these two answers. That means these two values of x are the points of intersection of these two graphs. So that means this point here, this point of intersection, this is supposed to be what? 146.3 degrees. And the other point of intersection, this one, this is supposed to be 326.3 degrees. So we have the points of intersection of these two graphs. Okay. Now in the last part, it says, use your answers to parts 1 and part 2 to find the set of values of x for x between 0 and 360, for which 2 cos x plus 3 sin x is greater than 0. Okay, now let me write that down here. 2 cos x plus 3 sin x is greater than 0. This is the inequality that we want to solve, that we want to find the answers for. Let's rearrange this. What two graphs do we what two graphs do we have here? 2 cos x and minus 3 sin x. We can write it like this. We can say this is 2 cos x greater than minus 3 sin x. So on the graph, you basically have to look for that region where 2 cos x is greater than minus 3 sin x. The 2 cos x graph is drawn in orange there, and this minus 3 sin x graph is drawn in green there. Where is the orange graph above the green graph in that diagram, in that sketch? Where is the orange graph above the green graph?
After 326.3.
After 326.3, that's one part. Is there any other part on the graph as well, where the orange graph is
Sir,
above the green graph?
after 90 degree.
After 90 degrees? Before 90 as
Before.
well? So basically until this point, until 146.3. So you would say the solutions to this inequality would be x between, remember the interval is from 0 to 360. You can't go beyond that interval. So you'll say the first interval is from 0 to 146.3 degrees. 146.3 is not included because we don't have an equal to sign here. At 146.3, they are equal. Since we don't have an equal to sign here, we don't put an equal to sign here as well. This is one possibility. Or x is between, x is this region, right? This yellow region. That's between 326.3 degrees and 360 degrees. That's the other interval of x that we get. These are going to be the two solutions that you get from this. Is that all right? So you know the points of intersection. You just look at the graph and see where the graph of 2 cos x is above the graph of minus 3 sin x. Since you already know the points of intersection, you can figure out, okay, towards the left of this point, towards the right of this point, and that gives you the possible values of x here. Make sense? Any problems, anyone? Okay, good. Let's have a look at one last question then, and then we end. Tomorrow we do coordinate geometry. Okay, what was that one now? Okay, it looks very similar to one that we've just done. But let's try this anyway. So I'm a part 2 of this, or part 1 as well. Both parts of this question? Okay. Okay, so the first part says, solve this equation 3 sine square 2 theta plus 8 cos 2 theta equal to 0 for theta between 0 and 180 degrees. 3 sine square 2 theta plus 8 cos 2 theta, that equals 0. And theta is between 0 degrees and 180 degrees. Now again, since we have something other than theta or x here, we have 2 times theta, we can use a substitution. It's going to make things easier if we use a substitution right away. Okay, it will save you from confusion while applying identities as well. You can right away use a substitution here. You can say, let a equals 2 theta. Now, if a equals 2 theta, what about the corresponding interval for a? It's going to start from 0. And then when you input 180 here, that gives you 2 times 180, that's 360. So this equation therefore becomes 3 sine square a plus 8 cos a equal to 0. And now you just have to solve this equation. Okay. Now we first have to convert this equation to a form in which we only have one kind of function. Right now we have sine and cos, both of them. What we can do is we can convert sine square to cos square. So we can say this is 3 times 1 minus cos square a plus 8 cos a equal to 0. Let's simplify this. That gives us 3 minus 3 cos square a. plus 8 cos A equal to 0. Let's multiply the whole equation by minus to make the quadratic term positive. That just to simplify things a bit, it gives you 3 cos square A minus 8 cos A minus 3 equal to 0. You can also think of it like this, that you just take all terms to the other side, and that gives you this. Now it's a quadratic equation. You can solve it like a quadratic. You can do it directly, or again, if you want to use a substitution, you can do that. You can say, for instance, so that will be too many substitutions though, but you can factorize it directly if you want. Okay, without using a substitution. Can we factorize this? Yeah, we can. So if you want to do it directly, you would do something like this: 3 cos square A minus 9 cos A plus cos A minus 3 equal to 0. Just break the middle term. Take 3 cos A common here. That leaves you with cos of A minus 3 plus 1 into cos of A minus 3 equal to 0. You get two factors from that. One factor is 3 cos A plus 1, and the other is cos of A minus 3. This is one possibility. This is one possibility. Or you could use a substitution as well. You could say, let C equals cos of A, right? And then use that substitution like this: 3C squared minus 8C minus 3. Or another letter, you could use U or whatever else that you want to use. It doesn't really matter. And factorize it after using the substitution. That's also okay. So this will become 3C squared minus 9C plus C minus 3 equal to 0. And that gives you the same two factors like that: 3C into C minus 3 plus 1 into C minus 3. That equals 0. Then you have 3C plus 1 into C minus 3 equal to 0. That means C is either equal to minus 1 over 3 or C equals 3. Now put that substitution back. You say cos of A is either equal to minus 1 over 3 or cos of A equals 3. Now this is not possible. You can't have cos of A equal to 3. Cos is supposed to be between minus 1 and plus 1, right? So this is not possible. So you ignore this one. So this is not possible. You can try taking cos inverse of 3. You'll get an error for that. What about the other one? Let's find the basic angle. Cos of alpha equals 1 over 3. What's the basic angle? Let's find the basic angle for this.
70.52.
70.52 degrees. So you have the basic angle. Now you look for quadrants. Which quadrant is it supposed to be in? Cos is negative. So cos is negative in the second quadrant or in the third quadrant. So you could either be here or you could be here. Now, what's the interval for A? A could be between 0 and 360. So one possible value of A is going to be this, and the other is going to be this. So you have A equal to 180 degrees minus 70.52 in the second quadrant, or A equals 180 plus 70.52 in the third quadrant. And then A equals either 120, no, 109.48, or it equals 250.52 degrees. Now, what was A? What was that substitution? A was 2 theta. Let's put that back. So we say 2 theta is equal to this. That means theta equals 54.74. And theta equals 125.26 degrees. These are the two possible values of theta that we get from this. And yeah, that's what we were looking for, the values of theta. Make sense? Okay, sorry. So Hazim is saying it was 70.53 instead. Let's use that. It was 5.3 after rounding off. If it was 5.3, it doesn't make much difference in the final answer. That's the benefit of using more significant figures or more decimal places, because even if you make a rounding off error, in this case, it would not get penalized because you already have more decimal places. So last decimal place, even if it's wrong, you would end up getting away with that, as long as it rounds off to the correct value in 3 significant figures. But let me just check. In this case, 1 decimal place, in fact. But let's see what this turns out to be. 4.7 here. And then this also becomes 5.3. So this is going to be 2.65. And this is going to be 2.35. And you could round it off like this, 54.7 degrees and 125.3 degrees. These are the possible values of theta that we have here. Make sense? Is this all right?
Yes, sir.
Just give me a minute, I need to send a message. Okay. What about the second part now? Now this is very similar to what we've done before. In fact, it says the diagram shows part of the graph of y equals a plus tan bx, where x is measured in radians and a and b are constants. The curve intersects the x-axis at minus pi over 6, 0, and the y-axis is 0 under root 3. Find the value of a and find the values of a and b. Again, you have 2 points given. You just have to input those 2 points in the equation, get 2 simultaneous equations, and then solve them. Right? Let me just do that quickly. Y equals a plus tan of bx. 1 point is minus pi over 6 and 0. Let's put that. Minus pi over 6 and 0. And the other point is 0 and under root 3. Okay, so you get 0 equals a plus tan of minus pi over 6, that's the value of x, times b. Okay, what about the other one? From that we get under root 3 equals a plus tan of 0 times b, right? X is 0, 0 times b, that becomes 0. Under root 3 equals a plus tan of 0. Tan of 0 is 0. So you get a equals under root 3 from this. Okay, the value of a turns out to be under root 3. That's one thing that we were looking for. Put that in the other equation. That gives you under root 3. In fact, 0 equals under root 3 plus tan of minus pi over 6 times b. Okay, so that gives you tan of minus pi over 6 equal to, minus pi over 6 times b equal to minus under root 3. That's the equation that we get. Okay, so you can either solve this, or looking at the graph, could we think of the period of the graph somehow? It's crossing the x-axis at minus pi over 6 on that side. One possibility is to solve this equation, right? But I'm just thinking of maybe a quicker way of doing this somehow. So if you think about the number of cycles, but it's not clear how many cycles we have here or what the period is looking at the graph. So yeah, we'll just have to solve this. theta is between 0 and 180. Keep that in mind. Okay, let's solve this. So this is negative under root 3. Let's find the basic angle. Tan alpha equals under root 3. What's the basic angle that you get? In radians, is it pi over 3? Is the basic angle pi over 3 here?
Yes,
pi
sir, it's
over
pi over
3.
3.
Okay, basic angle is pi over 3. Now tan is negative. That means it's going to be either the second quadrant or the fourth quadrant. Does it say anything about A and B being positive or negative? It does not say that. The graph shape looks like this. That is negative. Okay, so tan is either the second quadrant or the third or the fourth quadrant. Now we could have one value here. This could be pi over 3, or we could have here, this could be pi over 3. So we could say either minus pi over b equals this value here. Okay, this is minus pi over 6 times b. That equals this value, which is going to be pi minus pi over 3. What does that give us? Minus pi over 6 equals 2 pi over 3. What's the value of b that turns out to be from here? What value of b do we get?
-4.
Minus 4.
Minus 4. Okay. If we consider okay, let's just try another one. We do not really have an interval for this as such. This is supposed to be b times x. We know the interval for x, or do we? No. Okay. Let's see what value we get in this case. I'm just thinking about something. I'll just explain that to you in a moment.
Sir,
If we just give me a minute. So let's figure out if this was here, minus pi over 6 times b, that equals minus pi over 3. This could be another possible angle, right? What does this turn? What does this give you? This gives you b equal to 2. Okay, that's another possible value of b that you're getting. And if you go here like this, that will give you 2 pi minus pi over 3. On the other side, you'll have minus pi over 6 times b, and that's still going to be a negative value. Okay. So the negative value that we're getting for b is -4, and the positive value that we're getting for b is 2. So how am I getting those values? The first value that I'm getting on the positive side is this, and that's giving me b equals -4. The first value that I'm getting on the negative side is this, and that is giving me b equal to 2. Now we need to figure out whether b is negative or positive. The question does not tell us about that. The question does not tell us whether b is positive or negative. It just says a and b are constants. Now think about it. We have tan of bx. A plus tan of b times x. Now b could either be positive or negative. B could either be positive or negative. What's the shape of the tan graph? What's the actual shape of the original tan graph? It looks like this. And that's exactly what this graph is showing us as well. It looks like this, right? If b was negative, what happens when you have a negative number there? the graph is reflected horizontally. So there's a reflection in y-axis. If that reflection had happened, the graph would have become this. And that's not the case. The original tan graph goes like this. Okay, and that's exactly what's happening here as well. If it was reflected, it would look like this instead. That means the number b has to be positive. It cannot be negative. So we do not consider the negative result here. We only consider the positive result. This is not possible. B is supposed to be greater than 0. So therefore, that means B is equal to 2. Does that logic make sense? Abdullah, you were saying something?
Sir, can't we use substitution?
Substitution. Yeah, you can use substitutions. I was just thinking the working is too long already. Yes, you can, for this, you can use substitution, yes. So for this part, if you want to use substitution and then do it, you can do that, okay? I just did it directly here. You can do it using a substitution as well. All right, but the main thing is that you need to understand B is supposed to be positive here and not negative. Okay, now, Aima, does this make sense? Any problems?
No, sir.
Okay, so I just want, before we end, I just want to have a look at the marking scheme of this person to make sure if this is the only method, or do we have anything more efficient that we could use? This is March 19, paper 1, variant 2. Before we end, let's just have a look at that quickly in case we have maybe a more efficient way of doing this. P1, this was March 19, paper 1, variant 2. That's number 7. Okay, so yeah, that seems to be the only way to do it then. Let's have a look at the examiner report as well. That mentions anything interesting? This was March 19. Okay, we don't have examiner report of this here. Okay, all right. So yeah, that's what you would have to do then. Okay, you'll have to solve it like this and then figure out that it can't be the negative value, it has to be the positive value. Is that okay? Any problems, any confusions before we end? Any confusion? No? All right, so that's it then. I will see you again tomorrow. Tomorrow we start coordinate geometry then. All right. Okay. Allah Hafiz everyone. See you again tomorrow.
Allah Hafiz, sir.
Allah Hafiz.